So I want to begin by graphing a function. We're going to graph f of t equals cosine of t. And as you've been doing since at least late in grade school, to graph functions, you plug in values for your input value, in this case t, get out values for your output value, f of t, which is cosine of t. So you're going to plug values into the cosine function. So I gave you a sheet to fill out before turning on this video, and if you have not done so, I'm going to ask you to turn off the video, fill in the table. If you have to, go ahead and forward the video a little bit more and look at it, but you should be able to have filled in those values of cosine of t on the table. Again, look and pause the video if you have to. Hopefully you could do that without looking at the table. Now to graphing functions like, or graphing values, output values like negative root 2 over 2 and negative root 3 over 2, we don't really have a spot necessarily on our graph for that. So I'm going to put in some decimal approximations here. Of course, you know that 1/2, I'll put in some decimals here. 1/2 is 0.5. Root 2 over 2, you can do that on your calculator and ask it for a decimal approximation. I'm going to put it at 0.707. And that's probably even overkill in the accuracy, because when you're trying to graph, you're not going to be able to pinpoint down to the thousandth on your graph. Root 3 over 2 is 0.866. Of course, you know 0 and 1. I just put those on there for the sake of completion. And the rest you can get on there, hopefully. Again, I'll ask you to pause the video here, students, and fill in the rest of the table. So hopefully you're able to fill in those decimals, and now I want to get those points on the graph. Before I go too far, I want to take a look here, and just as a reminder, as an aside, you don't necessarily need to put this in your notes, but let's go back a few steps. And again, this doesn't have to go in your notes, but just for a point of reference here. Let's suppose you were asked to graph y equals the square root of x. And your teacher asked you, or gave you the table, and had you plug in values 0, 1, 4, 9, and 16. Of course, you got your output values. Now, a mistake that a lot of grade schoolers make, that I hope you wouldn't make at this point, but I just want to bring this up for a frame of reference, is that if you were making your graph, you would not label your x-axis 1, 4, 9, and 16. Even though those are the input values that I gave you, okay? So people sometimes have a tendency to do that. Again, most people learn not to do that by grade school, and I trust that, okay, in trig classes I usually have one or two who do something like that, but I trust that you know better at this point and wouldn't give me a graph. Oops. That looked like that, okay? I trust by now that you would know to number these pretty consistently. I don't have to write down numbers on every single hash mark here, but I can number every other one. Let's say 2, 4, 6, 8, 10, 12, 14, 16. My point is to keep the numbering consistent here. I've decided it makes sense. I had enough room. Make each hash mark worth 1. And so I didn't need to put a number on every one, but I went every 2 hash marks. So person reading this can see that, okay, we wrote down numbers every 2 hash marks, and we wrote even numbers here, so every hash mark is worth 1 on the graph. And to graph that, again, you don't need to put this in your notes. I'm just doing it as reference. 1, 2, 3, and 4. Am I writing big enough to show up on the video? Okay. So I've got points 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. Of course, this would be more accurate if I was doing it on graph paper. And you get an idea to draw a curve that looks like that. Okay. Why did I do that? Why did I waste your time with that? Well, these input values are perhaps not all that familiar to you. I've given you enough grids on your, or hopefully you've printed out enough grids to be able to do a lot of this yourself. But these might not be all that familiar to you as to what the spacing is between them. It might be helpful if I put in the degree equivalent, and that's why I left, hopefully, a column to the left here to remind you to put in here that this is at 0 degrees. This, remember, pi is 180 degrees. Pi over 2, half of that is 90 degrees. Pi over 6, 1/6 of 180, would be 30 degrees. Pi over 4, 1/4 of 180, or half of a half of 90, this is at 45 degrees. And pi over 3, 1/3 of 180 is at 60 degrees. So what I wanted to point out is that the gap here is 30 degrees, whereas the gap here, 15 degrees, then 30 degrees again. So I am not going to label my horizontal axis here, in this case my t-axis, I'm not going to label it 0 and then pi over 6, pi over 4, pi over 3, pi over 2. Those input values aren't evenly spaced. Much as the example I just erased, you wouldn't go 0, 1, 4, 9, 16 here. Okay, you'd stay consistent. So I'm going to look for a common denominator here. Think of every 15 degrees or pi over 12 if you need to, and I don't think most of you will need to. Just as a reminder here, though, I'm going to number these as 2 pi over 12 to have a common denominator, 3 pi over 12, 4 pi over 12, and then this is 6 pi over 12. So you can see again the spacing here where it was 30 degrees. Am I out of the frame? No, you're great. Where I was 30 degrees and then 15, 15, 15. And I want us to start to think in the, I know, less familiar and comfortable radians, but this gap is 2/12 pi, and then 1/12 pi, 1/12 pi, and 1/12 pi. So on my horizontal axes here, I'm going to make each of these hash marks 15 degrees or pi over 12. That means I've got to go 2 hash marks in to get my pi over 6, followed by my next one that's pi over 4, and then pi over 3, and then it's 2 more, 6 pi over 12, before I get to pi over 2. Okay. For my x coordinates. Now let me start putting some points on here. I've got 0, 1 I'm going to make the top, I'm going to make this one right here. Now I'll make this one up top. So pretty clear to the reader then, if 1's up top, this is 0.5. I don't need to write all the numbers in. These are pretty obviously 0.25 and 0.75. Let me get some dots on the graph here. That's not one of them. I'm going to start here and put in that when t is 0, cosine of t is 1. That's up here. Then when t is pi over 6, cosine of t is root 3 over 2. Again, decimal approximation helps here. So pi over 6, remember that's the second hash mark, and you've got graph paper in front of you, which makes it a little bit easier than me trying to eyeball it. Let me see. This is a half. This is 3/4, which is 0.75. Halfway between here and here would be 0.875, so 0.866. Yeah, just a tad lower. Here at pi over 4, root 2 over 2, 0.707. Here's 0.75, a little bit lower. Here at pi over 3, I've got a nice easy 1/2. And then at pi over 2, I am at 0. All right. So that gives me some of the points. And what you see here is I've got a bit of the curve. Now I'm going to ask you to pause the tape and see how you do graphing the rest of these points.